Okay, so now we are going through the rules of differentiation that you're going to need to know for your paper 1. Okay, now I've put a list of the different rules of differentiation that you have to know for the whole of differentiation, which is paper 1 and paper 3. Okay, I'm just giving you a run through, and then we're only going to look at the ones that are going to be necessary for paper 1. Okay, so in this list I've put, let me give them numbers: 1, 2, 3, 4, and 5. Okay, you have about 5 different rules or rule sets that you're going to need to know for you to know the whole of differentiation. Okay, but remember, we are splitting it into 2. We're giving you some part in paper 1 and some part in paper 3. Okay, or for those that are going to write paper 2, it'll be some part in paper 2. But for most, it'll be paper 1 and paper 3. All right. Now, what is coming for paper 1 is only the first 2 rules, which are the power rule and the chain rule. Those are the only ones that are coming for your paper 1. And I'm going to show you that just now in the syllabus. All right. Now, the next is going to come in P3. So we're going to cancel it out. And that's going to be the product rule. Okay, so we can cancel it out. And then the quotient rule. And then standard derivatives, which is, we can't really say it's a rule, but it tells you what you get when you differentiate trig functions like sine x, to say, okay, if you differentiate sine x, you're going to get cos x, okay? And if you differentiate e to the x, you get e to the x again. So these are derivatives of trig functions and derivatives of exponentials, things that you can't meet in chain rule and product rule and the other rules. All right, these are just some that you'd meet. That's what comes under standard derivatives. All right, so you're going to have to know about these 5 things, and then you start applying them. So for paper 1, you're only going to have to know the first 2, power rule and chain rule. Then all the questions that are going to come are going to be application of these 2 rules. We'll start applying these 2 rules. So you're going to have to know. I'm going to go to the syllabus right now, and I'm going to give you a quick run. Let's go to the syllabus. This is the page that talks about it. Okay. If you look here, it says here is notations. Okay. This part is notations, which we have done. The notations, the first and second derivatives, we've seen them. Now here we are at the rules. The next thing, it says use the derivative of x to the power of n. Okay, this is the power rule. Okay, so you must know the power rule. That's what it's saying. Okay, to me it'll be saying they must know the power rule. Okay, for any rational n, whatever it means. Let's go. And then they say together with constant multiples. Let me highlight constant multiples, sums, and differences of functions. So now power rule has situations when which I'm going to show you just now, when you have some number multiplying your function, some constant multiplying your function, and we have something we do to the power rule, although I'm going to teach you a shortcut again, all right? But I just want you to make sure you are comfortable and you know that you actually do know everything on this page. So here it says you must know the power rule, right? And you must know the power rule when there is a number multiplying your function, constant multiples, right? Or when you have 2 functions adding each other, which is sum, or when you have 2 functions subtracting one another, which is differences of functions. So we are applying the power rule to one function, and you are applying the power rule to one function that has a number multiplying it, or you have the power rule to functions that are adding one another or functions that are subtracting. We're still going to be applying the power rule to those situations. Now here, and then says, and of composite, use the derivative of x to the n, which is power rule, and of composite functions using the chain rule. So if I put numbers on rules, this is first, then chain rule is second. And where does chain rule work? On composite functions, which means the function of a function. You have one function inside another function. Then we say we have composite functions, all right? And in this situation, when you have one function inside another function, then you are going to use the chain rule. Okay? Mind you, I didn't say multiplying. I said a function inside another function. Then you're going to use the chain rule, because those are what we call composite functions. So we only have 2 rules to know, because the very next statement is now saying apply. So it's now application of differentiation. You have gone through the rules, and now the next thing is just to apply the two rules. So the only rules you have to know is power rule and chain rule. You have to make sure you're confident in those two rules. And then you're going to start to apply them. To apply them to get the what? To get the gradient of a curve. Okay, if you want to get the gradient of a curve at a certain point, then you're going to have to use differentiation. Okay? And remember, you'll be using a certain rule to differentiate. For you to get that derivative, you're going to use a certain rule, which is power rule or chain rule. Okay? And then you use it to get the gradient. Now, to get a tangent, okay, you know that tangent is just a line that represents a gradient at a point. So it's the same thing. And normals, okay, normal is a line that's perpendicular to a tangent. So we are seeing some applications there. Application 1, I'll call it A. 2 is tangents. Normals 3, okay, or C rather. And then to check if you have an increasing or a decreasing function, which is concept number 4. And for rates of change, this one is, you see how it has connected rates of change where you use the chain rule again. So you'll be just using the rules that you would have learned to now apply differentiation to get what? Gradients, okay? To get the gradient of a curve. To get what? The tangent, okay? To get to the gradient of a tangent, okay? To get what? The normal line. The gradient of the normal line. To get what? Increasing and decreasing functions. Or the equation, sorry, I wanted to say equation of the tangent. Of course, you use differentiation to get the gradient, which is put in the equation of the tangent. And you use differentiation to get the gradient, which is going to be put in the equation of the normal line. So that's why you're going to use differentiation for that, to get the m. We'll see it just now, okay? To get the m, which is like the gradient, which we're going to put in the equation of the normal line. So we are now applying our knowledge to practical situations. Because remember, this is a practical topic. Now you're going to check if a function is increasing or is decreasing, which we'll look at again in the next videos. And you're going to check rates of change, because that is the job of differentiation. Remember, differentiation and integration are part of calculus, okay? And calculus has two branches. One that gets the total of things, okay? How things accumulate over time, the total. And then the other branch that checks how things change, dynamic things, which are things that change over time. How they change, okay? That is what we mean rate of change. So the part that checks how things change, we use differentiation to find that. To find how things total, we use integration. So, okay, that's just it. Now, look at the last part of application, finding stationary points and to find their nature, okay? So that is just you now applying. What I wanted you to see is that you only have two rules and then you start applying. So you can make a list, you can do the two rules, and then you can put down a list of the things you are going to need to apply those two rules on. Okay? Gradient, equation of a tangent, equation of a normal, check if a function is increasing or decreasing, check the rate of change, and find the turning point, stationary point. Okay? It's also called turning point. And that's it. You're done. Okay? So this connected rate of change, that's what we're saying. You'll be using the chain rule. We'll see it just now, and we'll be done. Okay? That's it. See you in the next video where we now go through these two rules. Now you know that they are the only rules that are needed for your ASP1 mathematics. Bye for now. See you in the next video.